Today we're going to learn how to factor difference of squares. Let's go ahead and get started with a pretty basic example. We have x squared minus 25. Now, up until this point, we might have seen factoring a little bit differently, because up until this point, we might have seen factoring where we have three terms, but there's no middle term. The other thing that we could do is when we've seen them with no lead coefficient, we could just go ahead and jump right to the answer. So we know that we're going to factor this, and factor means to pull it apart. And so we're going to factor this into two things. And if I would just look at this, I would have to look at how did they get the first part. They'd get an x times an x. And that would give me the x squared. But where would the negative 25 come from? Well, that would probably come from 5 and negative 5. And actually, when we have difference of squares, it's that simple. We can just pull it apart by looking at what's the square root of the first part, the square root of the second part, and then have one negative, one positive. Now, the reason this works is because I'm about to multiply this out. When I do that, I get x squared minus 5x plus 5x minus 25. And so when we end up multiplying those out, because they're the same, the middle parts, they cancel out, which would leave us with just x squared minus 25. But these are actually pretty quick problems because we don't have to multiply it out if we see the pattern. So the things we want to look for is, are there two things we can square root, and are they a negative in between them? So let's see. Let's look at another example. All right, so again, we only have two terms, and there's a minus, so we can jump right to our answer. As long as they square root, we're golden. So what's the square root of 9x squared? 3x. And 3x. What's the square root of 4? 2 and 2. One of them has to be positive, one of them has to be negative, and done. So this actually works out pretty quickly. We actually would prefer if it's difference of squares because we can jump right to the answer. All right, here's another one. Let's see if this one's square roots. Whenever we see a binomial, we say, well, does it square a root? This one, though, it looks like maybe I can take something out of both of them. Can I take out a common factor? Is there any number that goes into 16 that also goes into 49? No, I don't think so. So I'm just going to go ahead and square root it, and then we'll see what we end up with. Square root of 16 is 4. And the square root of t squared is t. Then we've got the square root of 49, which is 7 and 7. One of them positive, one of them negative. I like to double check at this point that there's not anything that I can take out still, because I was pretty sure 16 and 49 didn't have any common factors, but now when I look at 4 and 7, I know they don't have any common factors. All right, so again, we have a binomial on this one, except when I go to square root it, I don't know what the square root of 2 is. So that's going to be a problem. I guess we could say that this one is done. It would be easier if we just erase the 2. But I could try to square root the 50, but that doesn't work either. So there is one thing I can do. Did you notice that they both, I could take a 2 out of both of them. I could take out a common factor. And when I do that, I get 2 on the outside, y squared minus 25 on the inside. Now this one, if I just focus on the inside, it looks like a difference of squares again. So 2, and then I have a y minus 5 and a y plus 5. It doesn't matter which one of these goes first, but it does matter that we still have that 2 on the outside. All right, let's do one last example. So this one, it looks like we can do square root of 4 and square root of 9. But wait a second. If I try to do square root of 4, I get 2. But what's the square root of x? I don't know. It doesn't work out. So this one's going to be a little bit tricky. It doesn't look like anything will work because I can't square root either one. And there's no common factors. So this is actually a dud. So I'm going to give you a little twist on this. Well, it was a dud because the 4x was there, but what if it was a 4x squared? Are we good now? Would that still not work? Let's try. If we square root the one, square root the second one. Well, that would give us 2x and 3. But the problem I have is that both of them would have to be positive, and that's not going to cancel out. So actually, if it is a plus, then it is prime. In other words, there is no factoring to be done. The answer is what we started with. We can't factor that at all. That's it. Today we learned how to factor difference of squares.